Top. Good. Musa Galadino.
Yes, the last topic that we treated in our previous class was atomic structure.
Class for who? We treated atomic structure, whereby we talked about the divisibility of atoms into proton, neutrons, and what? Electrons. Proton is positively charged, electron is negatively charged, whereby the neutron is zero, is neutral. It has no charge. It has no what? Charge. But before then, what is atom? Class, what is atom? Amina, English, what is atom?
Atom is the smallest particle of an element which takes part in a chemical reaction.
That is right, that is correct. Atom is the smallest particle of an element which can take part in a chemical reaction. Today, we are considering a subtopic under atomic structure titled as isotope. The subtopic we are considering this morning is isotope. Class, what is isotope? What is isotope? Amina Abubakar, what is isotope?
Isotope is a phenomenon whereby atoms of an element exhibit the same atomic number but different mass number.
Isotope is a phenomenon, is right, whereby atoms of an element exhibit the same atomic number but different mass number. What's responsible for this is because of the difference in the number of neutrons. The difference in the number of neutrons created what we have as isotopes of elements because of differences in the neutron number. Let's write.
Sir, before you start, I have a question.
Okay.
Who is the first person that contributed with the knowledge of isotope?
Yes, the first person that contributed to the knowledge of isotopes, they are the scientists who have done one or two experiments to discover the proton number, the atomic number, the neutron number. We have many of them. We have J.J. Thomson, who discovered the proton and what? And the electron. Also, we have Lord Rutherford, whose model is the acceptable model among all the models stated by the scientists who contributed to the structure of atom. Because he was able to tell us that atom can be divisible into proton, neutron, or electron, in which the atom is having center concentrated with the most mass of the elements, protons and neutrons, and the electrons are what? Are revolving around the nucleus. Have I answered your question well?
Yes, sir.
That's good. Now let's write. Isotopy is a phenomenon, that is a known fact, whereby atoms of elements exhibit the same atomic number but different mass number. This is because of the difference. This is because of the difference in the number of neutrons in these atoms of elements. E.g., for example, oxygen 16, oxygen 17, oxygen 18. Look up, everybody. We can see this one as an example. Oxygen 16, oxygen 17, and oxygen 18. These ones are isotopes of oxygen, having the same atomic number but different mass number. This is because the neutron numbers are not the same. 16 minus 8, you get 8 here. 17 minus 8, you get 9 here. 18 minus 8, you get what? 10. 10 differences in their what? Neutron number. Also, we have carbon. Carbon 12, carbon 13, and carbon 14. All these ones are isotopes of carbon. Is that understood? Yes. Do you have any question as regards the definition of isotopy and examples? Class, any questions? Any question? Your question? I don't.
Why is that relative atomic mass of elements are not whole number?
Thank you. Clap for her. I like that question. Why is it that the relative atomic mass of elements are not whole numbers? They are in fraction or decimal. They are in decimal, not in what? Not as a whole number. The reason is because of the presence of two or more isotopes. The presence of two or more isotopes responsible for the relative atomic mass of elements not to be whole number. We are going to that now. We are going to that. Here, we have explained that neutron numbers responsible for differences in mass number. Now, let's go to an example. But before we go to calculation to really explain why the relative atomic mass of elements are not whole number. Class, what are the other isotopes you know? For example, what are the isotopes of hydrogen? Class. Adami Dawood.
Hydrogen 1, hydrogen 2, and hydrogen 3.
Give me a round of applause. That is good. We have hydrogen 1, known as hydrogen. Hydrogen 2, known as deuterium. Hydrogen 3, known as tritium. These are the isotopes of hydrogen. Apart from that, what other elements also can we mention that exhibited isotopy? Class? Ishaq Sulaiman. Give me a round of applause. Chlorine 37 and chlorine 35. These are the isotopes of chlorine. Isotopes of what? Chlorine. Now, let's go to examples. Examples of elements that have relative atomic mass not to be what? Whole number. Number 1, an element, right? An element has two isotopes. Let's take for instance, the element has two isotopes, isotope 12 and isotope 13. Are we clear? Isotope 12 and 13. Isotope 12 and 13 with abundance of 98.9% and 1.1% respectively. That is one after the other. Calculate the relative atomic mass of the element. An element has two isotopes of S12 and S13 with abundance of 98.9% and 1.9% respectively. Calculate the relative atomic mass of the element. How do we do this? 12 is having 98.9% plus 13 of 1.1%. Now, we take the 12, the mass number, 12 times 98.9 into percent, 100, plus 13 times 1.1 over 100. We convert this 98.9% into a fraction, and this one into a fraction. Is this step clear? Is it clear, students?
Yes.
Is it understood?
Yes.
12 times 98.9. Punch your calculator.
1,186.8.
1,186.8 over 100 plus 13 times 1.1. 14.3 over 100. Is it clear?
Yes, sir.
From this level now, we can find the SCM. What is the SCM of both fractions? 100. So 1,186.8 plus 14.3. What is the answer? What is the answer? 12.011. So this is the relative atomic mass of that element. The relative atomic mass is what? 12.00. This is the reason why the relative atomic mass of elements are not whole number, because of the presence of two or more isotopes. The isotope of this element now is 12 and 13. Who can suggest, class, who can suggest the name of this element? Who can suggest the name of this element? Look up here. Who can suggest the name of this element? The relative atomic mass is 12.00. Who can suggest? Alamin Daoud. Carbon. Clap for him.